Hey guys, welcome back to another episode. In this episode we're going to be exploring the flavour profiles when you do neutralise certain acids and see how much they resemble the original product. So I went out and bought a nice apple cider vinegar. This is with honey and ginger and it comes with the mother. I haven't tried this yet, it's still closed. It's going to be interesting to see how it does taste with the honey and the ginger, both before and after we neutralise it. In the last episode, I spoke about neutralising it with sodium bicarbonate. This is great because it's very easy. It's just baking soda. So you can buy this in any sort of supermarket. When it reacts with the acid, it creates, acetic acid. When it reacts with the acid, it creates CO2, water, and also a sodium salt, based on this. Now, the issue, there's not really an issue, but I mean, at the end of the day, if you react quite a lot, if you neutralise quite a lot of product, you end up with quite a lot of salt in the solution. So it's be quite a salty solution. And I feel like that will, we'll find out today, but I feel like that will influence the flavour quite a lot. To combat this though, you can use a different sort of base instead of sodium carbonate. This is a bit harder to find, I could only find it in tablet form. This is calcium carbonate, so it's basically a carbonate made from calcium as opposed to sodium. Now, what's interesting about this is it's, aside from increasing your calcium levels if you take it in tablet form, when it reacts with the acid, it forms a calcium salt called calcium, let me double check this. This calcium carbonate, it creates calcium salt. Now, what's special about this calcium salt is that it's insoluble in water, and hopefully the solution that we're creating as well. So at the end of the day, we'll create a little cocktail here, which will have an acid component to it, but a nice balance between acid and sweetness. And it will have created CO2, water, and also this calcium salt, which will over time settle to the bottom and then can be filtered. So that's something interesting we're doing today. But first, we'll be tasting the cider, see what it's like, see if we can get any honey and ginger, and then we'll try and get a nice balance of bicarb soda mixed with that to try and neutralise and see what it tastes like. Alright, so I haven't got a whole lot of this stuff, but we'll give it an open and see what it tastes like. Boom, there you go. Nice crack. You can definitely smell the ginger off the nose. Give it a little pour. See what it tastes like. This is Mazzetti organic apple cider vinegar, just bought from the supermarket. Yeah, it's definitely pretty potent off the nose straight away. I'm not gonna lie, it tastes pretty horrible. So acidic. I don't know if this should be around 5%, like most of them are. We're looking at 4.5% for acidity. It contains organic apple cider vinegar, organic honey, and ginger extract 1%, and honey's 9%. The honey definitely comes through a bit more on the flavour than the nose. And there's still quite a lot of ginger as well, but first and foremost, that's definitely a vinegar. So what we're going to do now is we're going to try and neutralise a certain amount of this vinegar with bicarb soda, and we'll see how that tastes, see if it brings out any more of the ginger and honey notes. Alright, so what I'm actually going to do, guys, is before I experiment a little bit and start putting some bases into some acids, I'm going to do a little bit of maths and figure out exactly how much bicarb soda you need to neutralise a certain amount of vinegar, and I'm going to do the same with the calcium carbonate as well to see, because I just want to completely neutralise it and create like sort of a basis just to base our flavour profiles off. If I'm going to be changing it. I've done the maths on how much of each base will need to react with a certain amount of acid, and I've written it all down here just so I can quickly reference it, but I'll run you through exactly what I did. So we're going to start with the sodium carbonate, so we'll label this sodium. We had the balanced chemical equation for it as well, which I found online, which was CH3COOH, which is the acetic acid, and then plus the sodium bicarb, and that reacts to create CH3COONA, that's our sodium salt, plus CO2 and H2O. Because this reaction is balanced, it basically says that 1 mole of the acid plus 1 mole of the base will create 1 mole of the salt plus 1 mole of CO2 and 1 mole of H2O. We basically just need to figure out now, based on a given number of moles for this, we need to figure out, based on a certain quantity of this, how much of a quantity of this we need to create a certain amount of that. So to do that, we need the molecular mass of each molecule. So the molecular mass of the acid, looking online, is 60.05 grams per mole. And only because we need to figure out this as well, we need the molecular mass for this as well, which is 84.007 grams per mole. And that's basically it's a good way of understanding it. It's a concentration of, it's basically how much is in 1 mole of each of those substances. So there's going to be if in 1 mole of the acid, we're going to have 60.05 grams of acid. Okay. Now we're going to just use 50 milliliters of the vinegar as a base for the experiment. So 50 mils. We know that the acid component is 4.5% of that 50 mils, which roughly equates to 2.25 milliliters of acid. Now, the density of that acid at 21 degrees, looking online, is 1.05 grams per cubic centimetre, or milliliter. So we can figure out that that roughly equals 2.36 grams of acid. Cool. So now we know how much acid we have. We need to figure out basically how much base we've got now. We need to do this reaction. So if 1 mole of the acid reacts with 1 mole of the base, we need to figure out how many moles of acid we have in 2.36 grams. The best way to do that is to take the molecular mass, which is 60.05 grams per mole, and divide that by 2.36 grams. You see the grams cancel out. We are left with 25.41, and that's 1 over mole. And then just inverting that, we have 0.03934 moles. So basically, that many moles is going to react with the base to create our salt. Basically, that means we need that many moles of because this is a balanced equation, we need that many moles of the base as well. And it's just a simple conversion now back to figure out how much base we need. So we've got 0.03934, that's moles, and times that by the molecular mass of our base, which is that one there. You'll basically find that those two cancel out, and you're left with 3.3 grams. 3.3 grams of our base. That's the number we need. So basically, for 50 milliliters of vinegar, we'll be mixing 3.3 grams of the base. Looking at that realistically, it actually seems like a decent answer. We'll do the same for our calcium really quickly. We've got all our numbers here, so it's going to be quite easy to do. I'll quickly write out the formula as well, though. So we've got CH3, COOH, that's our acetic acid. Then we have CaCO3, that's our calcium carbonate. The salts looks a little bit more complicated. CH3COO plus H2O plus CO2. Now remember, we're testing both because this salt here is actually insoluble. So it won't add to the flavour if it's filtered out. Yes, so we've got our molecular mass of our acid here. We can include our molecular mass of our base, 0.869. That's grams per mole. Again, we're going to be reacting with 2.3 grams, 36 grams of acid as before, which is equal to 0.03934 moles. Nothing's changed in that respect, except now we're going to be converting the number of moles we need. Again, it's a 1-to-1 ratio. 1 mole of acid and 1 mole of base creates 1 mole of the salt. So we're going to be using this many moles, but with the new molecular formula. So it's a very simple equation. It's 100.0869 grams per mole times 0.03934 moles. They cancel out, and you're left with 3.94 grams of base. So you can actually see, just based on the fact that they're different salts, you almost need, what is that, 0.6 of a gram difference, which I guess is not that, but it's actually quite a lot when you're only dealing with 50 milliliters of acid. So we're going to jump back in the kitchen and mix all this together and see how it tastes. Alrighty, here we are again, as the plane's going over beautifully. We have everything we're going to be needing to create our solutions. The first thing we realised, this calcium carbonate is actually in pill form. It will dissolve, but we won't be able to get an accurate number of grams out of it. Each tablet is 600 milligrams, but we need a certain amount. So, where is that piece of paper gone? Just over there. We're going to need 3.94 grams. So, the best thing to do with this is probably just crack the seal and give it a good crush up. So I'll do that right now. Alright, so I'm back. We've managed to crush up the peels just a little bit. That should be to a precision where we can get the amount that we need. I found the best way to do it was get the back of a spoon and simply crush them. I tried blending them, but it made way too much noise. Alright, so we're going to weigh out our apple cider vinegar. We need roughly 100 grams, which would equate to about 100 milliliters. Should be more than enough. Density is about 1:1 with how many mils? So look around 50. 44, 46, 47, 48, 49, 50, 1, 2. That's why it's a little bit too much, to be quite honest. I'd rather get rid of all the acid and have a little bit of base in there than anything else. So that's 48. $50, beautiful. So that's going to be one of ours, and we'll do a second one just here. Good to know the glasses weigh the same. 30, 48, 49, 50, beautiful. So we have our two 50 mils here. We can get rid of these scales now. Bring out old trusty scales just over here. Now we need to be measuring out a certain amount of bicarb and a certain amount of calcium carbonate. Best way I found to do this is to get a little bit of baking paper and create a little bowl with it just there like that. Alrighty. So in terms of the bicarb soda, looking back at our numbers, we need 3.3 grams as the base. That's 1 gram. No, you can stay there. It's 1 gram. 3.1. 3.37. 3.33. Okay, 3.3. Beautiful. We'll put this into one of our solutions. And we'll do the same thing here. So now we're looking at 3.94 grams. So we'll put a few of our solid blocks on there. 3.05. We'll look for 3.94. 3.59. 3.99, take one of these off, maybe the smaller one. 3.90. 3.97. I'm probably being a bit too... Oh, look at that, 3.94 on the dot. And we'll put this into our other solution just here and let them both work their magic. So you're pretty much done reacting because you're in powder form, so easy. Let's wait till that settles down and finish them off as well. I'll be back when it's all done, guys. Alrighty guys, here we have our final product. So on the left hand side we have our solution that contains the calcium salt, the calcium acetate, and on the right hand side we have our traditional sodium bicarb, sodium salt solution. So I'm going to give these a quick test. I guess the biggest thing you can notice is the colour difference. That's because the salt on the left hand side and the calcium acetate isn't soluble in the solution, so it's in suspension at the moment. If you give it time and have a good look just at the bottom there, you can see it sort of forming. I've let these sit for maybe a few hours in the fridge just to cool and make sure the reaction had finished off. But yeah, that's the reason it's so much more cloudy, is you see the acetates are in suspension. So if you let this sit for maybe a day or so, it should settle out. It's a very, very light sort of mud at the bottom, so it's very easy to stir it up back into the drink, but with delicate handling you should be able to siphon off the all the goodies. On the right hand side it just looks like a regular apple cider vinegar. So we'll give these a quick taste test. I've got a trusty spoon here. I expect this one to be a bit saltier. Yeah, so that's not sour at all anymore. I still get a little bit of vinegar, a bit of ginger, not so much honey, but that's really quite salty. Now I did calculations as well. The amount of salt in the solution is about 6.5%. That's the salinity level, whereas regular seawater is about 3.5%. So it's going to be quite high in salt content. I think it could be used in cocktails, but I think you just need to really find a right sort of balance. This is the one I'm most excited to try. This is the calcium solution. So I'll just give my spoon a big puff. Give this one a taste. Yeah, so I can perceive a lot more sweetness in that one, definitely a lot less salt. I think the reason for that is, even though the salt levels probably exist in quite similar sort of quantities, the one on the left being insoluble, a lot of it's sunk to the bottom, leaving behind more of the cider vinegar solution. It's actually pretty tasty. There's actually not as much vinegar as the one on the right hand side, the sodium bicarb. And I think as a result of that, a lot more honey and ginger sort of comes through. So it's going to be interesting to see. Calcium acetate is hazardous in large quantities. So it's definitely not something you'd keep in the cocktail. It's something that you'd filter out for sure. So we've still got our gin breathing at the moment. It's going to be turning into gin vinegar soon. I tasted it earlier. It's definitely on its way. So maybe in the next week or so, we'll have another video and a bit more of an official cocktail. So thank you very much for watching. If you enjoyed it, please like and subscribe, and I'll see you next time. Cheers.